The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, good morning, wherever you are in the country. It's Mark from SolidCAM. We'll be doing our 30-minute free training session today. With me is Kevin Rankle. Hey, Kevin.
Hey, guys. Thanks for coming.
So we will continue our series on this part from start to finish. Pretty much, we're probably going to finish this today because if you guys remember from last time, we basically did everything on this part on side one. The only thing left to do is maybe some finishing touches. We actually only did these tapers on this side, so we need to do the tapers on the other side. So we'll show you how we can do that very quickly. And then probably just do kind of maybe like a final deburr or something like that on this side before we flip it over. So let's do those two, and then we'll look at how we get to side two. So since we've already done the work with HSS, morph between boundary curves on side one over here, or on the right side, I should say, we could do the same thing. We could do a save and copy, reselect geometries, or since there is a symmetry here, let's take advantage of that. So what we'll do is we can highlight these two operations, right click, and we'll go to the mirror operation. Okay, let me just bring this window over here. So what we can do with the mirror operation is we can add a new operation at its current position in the tree, which would be advantageous because if we want to save the save tool changes, maybe use the exact same tool, which in reality is probably what we're going to do, or we can add it at the end of the tree. This is a little useful if you're actually doing like a left side and a right side of the part, and you want to generate operations for left side, right side, but you want to do all the left side first and then all the right side second. That's when you could use that end of operations tree. But for what we're doing here, we're literally doing the same feature on the other side of the part using the same tool. We'll just say at current position in the tree. So it'll just shuffle it inside of there. Mirror about, and you could choose whatever plane you want to mirror on. And again, this could be left side, right side, maybe in Mac 1, the ZX plane, YZ plane, or any of the other Macs that you have listed there, or you can even add a new Mac. That's if you're doing a separate part. But again, we're doing the exact same part, a feature on the other side. We're going to rely on the symmetry of the part. I'm actually going to click on selected plane and look for a plane that adds that symmetry. So again, once you see this window like this, there's nothing for me to choose here. It's because it's waiting for me to choose something from the feature tree. So I'll open up the feature tree, and in my design model, my right plane seems to be that symmetry plane. It goes right down the center of the part. You kind of confirm that by just kind of looking at it like that. So if I choose the right plane and click the green check mark, you can see that we can get a little bit of a preview here showing us that it's about to mirror that exact toolpath there. And then finally, I could choose which coordinate system I'd like to place it under. So again, we're talking about mirroring a part. We might actually have a left side and right side under different offsets. So you have the ability to actually put it under a brand new offset. And when I click on this, it actually brings down a list of the coordinate systems I could put it under. But in this case, again, it's on the same part, just symmetry. I'll just use the current coordinate system. When I click OK, it does the calculations, and it adds the other two toolpaths there so that it's symmetrical. Okay. So anytime you see repetition or symmetry, always try and use the transform or the mirror command because that'll save you some time. And then, of course, that drilling operation was set to update its stock, so it wants to be updated because it recognizes a change to the stock. Nothing really going on there. I'll just right-click on it, and we can just do a quick calculation on that. So real quick, any questions on mirror? It's pretty simple. Anyone who's used the older mirror command in the transform command will remember that actually mirrors it 100%. So if you have a climb milling toolpath, it actually mirrors it to conventional cut. Whereas with this new mirror command, separate from the transform command, it actually retains the cutting direction. So this was mirroring that toolpath 100%. Sorry, I shouldn't say 100% because this is previously, but it mirrors the toolpath, but also keeps it as a climb toolpath. So even though it's mirroring the geometry, mirroring the direction, it still generates it as a climb cut. Okay, so this side is pretty much done. Just the one final finishing touch would be the chamfer. Chamfer recognition is what we're going to use. There are no chamfers on this part. What we're going to do is basically deburr it. And we covered this, I think, maybe early last week. So if we go to chamfer recognition, new geometry, It's looking for me to choose a solid to recognize. What I'm going to do is before I even click on the solid, I'm going to say ignore any floor or wall angle that is less than 90 degrees. So basically, I'm getting it to recognize that there's a taper there, so it's not going to try and chamfer this one edge right here and then all the other edges on those tapers there. So click on our solid. It parses the model, basically recording all the faces that could be horizontal faces that might have a deburring edge. So as you can see, everything highlighted in yellow is what it's going to try and deburr. I can turn on my 3D model protection just so I can check against the model itself, gouge checking, that sort of thing. Let's go to Tool, Select. And I believe we had a tool on here. If not, let's just add a tool. So let's go chamfer mill.
Like tool number 4.
Tool number 4, I guess we could have used tool number 4 as a spot drill, but we could have used it. So we'll use that. Levels. Since this is a solid recognition toolpath, it gives me the ability to tell it where I'd like it to recognize the solid. So from what Z level to what Z level. In this case, upper level, I'll start maybe at the top of the stock as a Z level, just to get that associativity going. And then the lower level, if I don't check that box, it's going to look at the entire part. It's going to look over everything. In this case, we probably can leave it like that because there's really nothing that I don't want it to check for, and there's really nothing out of its range. So don't need to worry about that. But if you ever are doing the chamfer recognition or any of these recognition toolpaths, and let's say, for instance, there's a very deep hole, and you don't want the tool to try and go down and chamfering down that deep hole, you can set a lower level to limit the travel of the tool, at least in the Z direction. And then chamfer depth, this is essentially going to be an incremental depth. From whatever plane it's on, whatever edge it's on, how much deeper into the part it's going to go to chamfer it, I'm going to put in maybe just 2 thou just to give it a little bit of a deburr, just kind of kiss the edge a little bit to get rid of those edges there. Technology, once you click in here, it is devoted only to chamfer. That's why the only things you really have control over here are the cutting diameter. So where on that tool, we're going to ride along that chain. So in this case, if I set it to 50 thou, wherever on the tip of the tool, 50 thou diameter sits, that's the level that the tool is going to travel across on all these chains. Cutting type, one way, we'll do climb. Safety distance or safety offset, that is, if you look in the bottom left corner there, that is the distance that the tool will get as close to the walls as possible. So we also have the 3D model recognition going on. That's going to look at the overall part to make sure there's no gouges, but this is just the default for anything around the walls. So this will actually trim any edge, for instance, this edge right here. This will trim back the toolpath to avoid gouging with this wall here. So that's the purpose of this guy over here. For whatever reason, if we needed to use this tool for any kind of roughing, or if we wanted to add any additional cuts, or maybe just a little bit of an overlap in certain cases, we have these options over here. And for the overlap, to eliminate any witness lines, I'll put in just 20 thou real quick. Link, let's put in our normal lead in, lead out. Maybe not so much of a big lead in. And save and calculate.
And if my deja vu, if I remember correctly, we had to switch that tip from 50 to something a little bit bigger because that one hole was getting a little close to the wall. Yep.
Yes, and that is these holes in here. So to eliminate that, we'll drop the tip by just telling it we'll use a larger diameter. So if this tool was a 1/2 inch, that makes sense. Let's go over here, and let's just say we're riding along 0.4. So now you can see it's able to complete that circle. There's my overlap to eliminate any kind of lines. And this should be completely machined out. So all circles, all edges. Okay. So let's say that's done. We're going to do side 2. So if you remember when we first started this part, we actually added a display state for those fixtures. So I'm just going to double click on side 2. And everything we see now represents side 2. Maybe not so much the stock, because you can see the stock is interfering with that fixture, but by this time, we've already milled all that material out. So that really the only thing that's left is whatever we see on this back side. And really, that should just be maybe whatever material is left on the bottom there, and this little fillet right here. So how do we do that? Well, first, we need to set it up. And if you remember again, from when we first started this part, we actually added the template for the probing. So these guys have been waiting here the longest time to be set up. So let's open this up. We're on Mac 2. We're going to set up our home position. We just need to set up our outside edge. And let's do it to the target. Only because there might still be some material left on the edges here, but we actually are going to probe on, well, actually probably, we have these faces here, and then we have probably just the last edge of the stock over here. So we should probably probe to that. What do you think?
Yep.
Yeah, okay, so let's get out of here. And let's see if we can use curve and close corners to close that up. So I'll grab this edge here, and then the edge of the stock here. No. We might need to add a little bit of an offset then, shouldn't we? I mean, we have only these edges here.
You can chain the your part like you originally did, and then we can just change the retreat distance.
Okay.
Or like Scott just wrote in there, you could probe up that bore too.
We could, but then we're not using the template, but we could. So let's get rid of this guy then. So first we can establish our Z since we already have this here. And that'll just be its line right here. So from the template, all of this is the same. We're just going to go to our Tech 1 and make sure that all of this makes sense. Show that. Let's make sure this is under Mac 2. That's coming in kind of weird, but let's see. Now, comes in clean. Except the levels might be off. Let's see, levels.
Go to your Tech 1. You get a minus shift.
Well, that's just the side shift. Why does it look like it's going too deep? All right, let's not use this template. So we'll add probe operation. This time, let's do the bore. So we just grab the circle geometry tool. We've already got that tool in there. Tool 1. Levels should be taken right from Mac 2, so 1 inch above the part. We'll jump right to Tech 1. Click the little eyeball. Z level. I'm just going to eyeball it by clicking somewhere on that right there. Why is it giving these weird numbers?
Roll that mouse. Yeah.
Yeah, I'll just do that. So you can do it like that. You can kind of eyeball it like that. But normally you should be able to click on this icon here and just grab and record the Z level that you're at. Number of touches. So you can see that if we kind of increase it, it does more touches around the circle. Basically, it's still recording that center there. You just do as number of touches as you want, 3 at minimum. Move start point. In the case of your bore, you might have maybe a keyway or something like that. You can always shift this guy around. Let's see if I can do it like this. So yeah, with the mouse, you can't really see it move. Let me put in a larger number in there. So you can actually shift it around. So let's say if there was a keyway where this guy is and I wanted to shift it to just get the nice curvature of the bore, you have that ability to put that in there. But I'll leave that at 0. And then of course the offset. So if we know that the chain I just selected doesn't actually represent the reality, maybe there is some material left over that I need to touch, we can put an offset in there. Otherwise, that is our probe, gets the center of that circle. And if we need Z, again, we just add probe operation. This time I'll do just a simple one, single point Z, and I'll just click on our top of stock. Let's do stock like that. Just right there. Tool is the same tool. Levels look okay. Tech 1, it's just looking for the Z level, and we're just going to leave it as that. So save and calculate. So now we've established our home. We can do whatever we want to this part. And since we have basically just a nice flat face, maybe a little bit of a fillet there, I could do 3D eye machining if I don't even want to think about it, or I can do 2D eye machining and take advantage of our stock recognition and get it to look at things for me. So Scott's question, does SolidCAM have its own macros, or does it use Renishaw installed macros? That I'm not sure of. Kevin, do you know?
Yeah, that's going to be all pulled off of the Renishaw macros. So like probe web, probe X, Y, Z, those are all going to be your Renishaw. Now, if you're not using Renishaw, then it would be set up custom macros.
So I've opened up 2D eye machining. I'm going to use that first option. That's letting me just grab a face. And from our updated stock, if I grab that face there, it's just going to extend that outwards and then machine the material. Let's go to Tool. I think originally we used Tool 57. Let's use Tool 57 again. And then it updates this, the preview to show us we've got that much material to remove if it extends outwards. Perfect. So levels, it read all that for me. Let's get this level 8 turbo. Technology, in this case, we'll leave 10 thou on everything. And let's go back to Tool, and we'll tell it to finish the floor. And that way it'll use a finishing of a contour style. Okay, and if you can kind of see that through the preview, the toolpath has machined all that material there. We'll do a save and copy. And what I'll do is I'll just change the geometry now to the lower level. And then everything should be the same. It should recognize my levels for me. You can see from the updated stock, done. I'll just save and calculate. Okay, so that should have eliminated all that material. Only thing left now is to do this little bit of a curvature there, and probably, it's probably not really any real chamfering to do, maybe just on the outside and the inside there. So let's see. If we go up to evaluate, curvature, I don't know why it's all black, but if I go over here, I should be able to tell the curvature is 1/4 of an inch. Okay. So that's the curvature of my little fillet there. So 1/4 of an inch. Just add a quick profile toolpath. And I'm just going to grab that chain right there. And see if I have my 1/2 inch ball mill. No. Oh, I do. Cool. Ball mill. Call this 1/2 inch. Levels. I'm just going to tell it to go from that face to the same face. So it gives me a profile depth of 0. But essentially, all I'm really telling it to do is just go down, kiss that surface, and go across. That edge represents the center of my tool. So I'll just say center. Or if I want to get some sort of cutter comp or anything like that going, I could still give it a left side, but then shift it using this. Negative 0.25. So that what that does is it actually tells it that chain to be considered inwards, and then I can still get my cutter comp applied to that new chain. That's just a modification of the geometry. But in reality, I'm telling it that the center of the tool is going to follow that chain. Okay, and again, we'll add a little bit of an overlap. Link, again, put some normal in there. Save and calculate. And we've machined that right there. And then finally, we can do our chamfer recognition. Now I'm adding these as we go along, but again, you could have actually just done a save and copy, changed it to Mac 2, and then just reapplied it, or reselect geometries under Mac 2, depending on the toolpath. So basically just repeating what we did before. So in this section, I'll grab tool 4. Levels, I think we're okay with that. Don't have to do anything there. Let's put this back to maybe just 300 thou this time. Normal. Don't need as much of a lead in. Save and calculate. Part is done. Okay. So let's see what we've done through this whole week. We'll do a solid verify. So since we assigned fixtures for side 1 and side 2, we'll actually see them pop up and disappear with each Mac. So let's just play through this. I have it set to color code each tool. So with each tool, we'll actually see what that tool has done on the solid. There's our stock representation. I'll just press play. There's our probing. So if I somehow incorrectly program the probe, like say I crash it or something like that, the solid verify will tell me that I crashed it. And as you see, since I did a simulate on the operations folder, it's going to go through each operation in order. It actually highlights it with a kind of a gray to show me what toolpath is being represented. So in this case, I know that I'm doing the first of my 3D eye machinings, doing a little bit of a scalloping on those tapers. That orange color tells me that I'm currently using tool 57. Now I know that only because I'm looking at it saying it's tool 57, so I just assume the orange is. But I would have defined this tool with a certain color. I would know that I'm looking at what was done by my first tool that I've assigned as orange. So while this is going on, any questions on what we've done today, previously, any questions for the future? We've got about 7 minutes left. I was just going to run through the solid verify just to check for any kind of collisions, to check for any specifics we want to talk about. What you'll actually see is once this gets down to the last of the toolpath, the chamfer, the fixture will disappear for side 1. The side 2 fixture will pop up, and then we'll actually see it do operations on the second side, and we can confirm anything we've done wrong or we've done right. We can see that there's no gouges.
And one thing you guys can also remember too is, let's say that center of that bore, we have plus or minus 0.2. So at the end of the at the end of the list, we're going to add another probing operation just to take a measurement off that that probed hole. And then for the next part, if you guys are running production, it would automatically adjust that comp if you guys are running like the Haas controllers and stuff like that.
And that could have also been a copy of one of our other probing operations, right? Okay. We could have just changed the parameters. Okay, so Scott does have a question. So notice the chamfers do not do the smaller holes. That is because I actually didn't point it out, but I left the filter on for a certain size of diameter to ignore. So if I had disabled that filter, it would have done all the holes. So that is a function inside the chamfer recognition so that you don't actually go and try and chamfer or deburr all the holes. Maybe some of those holes are going to be done with a countersink tool or as part of some other operation. So there are filters inside of the majority of our 3D recognition toolpaths to avoid certain things, like for instance, just wasting time going around a hole when really that same tool could have just plunged in there and made that same deburr, that same chamfer. So the smaller holes are probably smaller than whatever I've set as my filter, and that's why it ignored the smaller holes. Hopefully that makes sense. Okay, so I'm going to kind of jump ahead here. But while we're doing that, let me just jump back and show you what I was talking about. So geometry, new, apply filter, minimum diameter, 1/2 inch. So those holes, obviously those holes were smaller. I forget what size they were, but they are smaller than 1/2 inch. They're 3/8. So that's why I'd ignore those holes. So let's jump to, we'll do these final guys here. Actually, let's do all this. So you can see I highlighted what I wanted to show. It'll still give the gray highlight on top of the blue to indicate what toolpath it's currently doing. I just wanted to skip ahead from the iMachining stuff to get going. So let's press play on that. And there is a warning of the arbor machine stock. That is simply because, again, if you remember, we're doing horizontal machining in our HSM. And since we didn't do the walls first, it thinks that for my tool definition, that arbor is touching. It's rubbing there, which in reality, it possibly might, or I might actually have a reduced neck here, so it's not actually touching, but probably should have looked at that myself when we did the HSM and said, okay, probably need to add a little bit of a step down on the walls as well. So in this case, we were trying to just do the walls at the same time as the floor. That's the consequence of this toolpath. I'm just going to say for now, stop for current operation. And you can see the little red shows us that that's the rubbing of the arbor. And we're probably going to get that now for all those pockets because the tool does not have enough flute length to do the walls. And for that, I blame Kevin.
We're just going to go grab a different, longer tool out of the tool crib.
Okay, so same sort of thing. So if we take a look at, now this is an interesting one. I don't know why this is saying giving us any error, because this is from our chamfer recognition, and this should have automatically checked. So we need to see what we set up for that. But let's say we do stop for the current. And okay, so let's zoom out here. And I'm going to pretend that these errors that are popping up are intentional. Whereas this one kind of is, because it says there's a clash between the probe and the stock. Okay. So I'm going to say no. There's our iMachining. And then the finishing, and that same iMachining. And you can see from the stock recognition of the toolpath, it actually recognizes these little feet that were left behind here. So it's going to actually eliminate that once it does that next pass. Although the level's not the same, so that's probably why. Okay, there it is. Perfect. And then the ball mill passed by, and it did that as well. So a little bit of cleanup there. Probably just need to lower some levels on some stuff there. Maybe do a final pass on the outside. But the part is pretty much programmed. We just got to go and, like Kevin said, just get a tool that has a longer reach there, longer flute. Take a look at my chamfer recognition. But a few things here or there I can check and correct. Finally, before I go and say that this is done, I would go over here to this color-coded icon, and using my ranges here, again, we've talked about this one before as well. I have some number ranges and some color ranges. I'm going to check for gouges. So I'll click execute. It hides the fixtures, and then it just shows me what the status of my part is. So I actually have more than 4 thou material on that face there, on those walls there. And I know that because when we did our finishing, we didn't actually do anything that did the walls. We just did horizontal machining. So these walls were left alone because there actually is no wall floor for it to do. These are through holes. But the holes themselves, they have some coloring that indicates it's between 0 and 4/10, pretty much on size. And all these other surfaces have that yellow color indicating again as well that there's 0 amount of material there. The only thing that's left is, again, the outside wall, again, because we didn't do any walls. So I would go back and maybe use an HSM constant Z, or an HSM maybe spiral machining, spiral milling or whatever for some of these walls here. That would easily be done as well, maybe individually. And then anything that is missing in terms of, like we saw, those tabs that were left on the end there, I would go and maybe just do an outside profile on those as well. So some touch up, but as you can see, you get a good idea of the status of your part, especially on these corners. Maybe the tool can't fit in those corners there. Maybe I need a smaller tool. Maybe a rest milling operation is required. But this gives me a good gauge as to where I am and what I need to add. So any questions on this part? Okay, great. So this is the end of this part, start to finish. Actually, I guess the final thing would be to G-code it. So we'll just go G-code all. And I have mine set to open up in the default location of Notepad. But if you have something like Simco or Predator or I guess what, Eureka, yeah, any Edit NC or Ultra Edit or any of those guys out there, you can get your SolidCAM settings to point to that, and then it'll open up in that one. But Notepad is the default setting. That's why I still use it, because majority of our customers don't have the other softwares. When you open up your G-code in Notepad, it automatically saves it wherever you've told it to save it. So if I go to my settings, and we take a look at where I go to G-code generation, I have it set to save it in this location here, which just happens to be my temporary folder. But everything in this section is a different location where you can save your G-code. Say, for instance, your machines are networked to a particular folder location. You can actually set that up here in G-code directory and then browse to that folder location. And then every G-code that you output in any of your files goes to that same G-code directory. So that's good if you have a network location for your machines. But one note, if you're using Notepad, is it saves it under whatever file extension your post is sending out, and all you gotta do is just click exit. But if you happen to click File Save, what happens is, if we go to File Save As, it actually adds that TXT at the end. And some machines can't read that. Some machines you actually are trying to output a certain file extension because that's the extension your machine reads. If this is the case, and you've maybe made some manual changes and you want to save what you've done in Notepad, change this to all files, and then it'll actually save it with the proper extension. So you'll see the extension here. All you got to do is just click Save. But you have to do that with all files. And I believe that was the subject of another KevCam in the past. But that's it. You're ready to go. I mean, we talked about tool sheets. You could do tool sheets as well. But generally, you're just going to G-code this, send it out to your folder location, or load it onto USB, or even a floppy if you still have the machines that use floppies, and then the part is done. So what we'll do is we'll start another part tomorrow. I believe Kevin has one that's probably a good example of what he wants to show off. But for today, if you have any other questions, any other topics you want covered, Kevin's going to put my email in the chat section. And what you can do is you can send me your questions, your topics. If you've got a part that you'd like to see done from start to finish, or at least maybe have one particular toolpath covered on that particular part, go ahead and send me that part using the email that's going to be in the chat section. If you know anybody that can benefit from SolidCAM, please let them know. Give them our contact info, or maybe just give us their contact info and we contact them. If they go into a demo, you get a $100 gift card, I believe it's a Visa card. If they go into buying it, if there's a sale, you get 20% of that sale. So that is just free and clear of just letting us know that they're interested, and then they take the time to check us out. Like I said, we will continue this until the end of June. If you have any questions, my email is already in the chat section. For now, what we'll do is we'll end the session. We'll talk to you guys tomorrow at 2 p.m. Stay busy, keep safe, keep your family safe, stay healthy. Talk to you guys tomorrow.
Have a good one, guys.